Good evening and welcome to the BS and Beer Show. Of course, BS stands for Building Science. The topic tonight, which I know you're all excited about, is spray foam installation failures and how to prevent them. I'm Travis Brungart. I'm in Prairie Village, Kansas, a residential builder there, and tonight I'm drinking a City Barrel key lime pie, from a delicious co-branded Sashco and BS and Beer Show koozie, which adds to the flavor. I have to tell you. So BS and Beer is an independent grassroots movement to share building science knowledge through local meetups. And this, our Zoom show. The brew crew and our guests volunteer our time each month to bring you what we hope is a fun and informative discussion. We encourage you to start your own local group. And if you want information on how to get that started, you should visit thebsandbeershow.com and check out our December 2022 show where we explain all that. Of course, you can find the chat box icon at the bottom of the screen. You can post your questions and comments there. Be sure when you do comment to click all panelists and attendees or everyone, because otherwise Zoom tends to want to revert to the default panelists only, and then no one sees what you're trying to say. And your comments are often witty and help shape the show, so please make sure we can see them. The video recording of tonight's show will be available at Green Building Advisor. And of course, all past shows can be found there and also on YouTube through a link at thebsandbeershow.com. I want to take a moment to thank our media partners, Green Building Advisor and Fine Homebuilding Magazine. And with that, I'll turn it over to Emily.
All right, so tonight I get to talk about announcements, and we don't have too many. So surprisingly, everybody's on summer vacation. Nobody's doing anything in June except for our friends over at Builders for Climate Action. They released an updated version of their carbon accounting tool, the Beam Estimator. It's a great way to easily estimate the amount of embodied carbon in your project or compare different products and assemblies. The new version has updated values and many additional features. It's available for free, but well worth the suggested donation. And I also want to throw out there that they are doing a training in June. It looked like there were only 3 more spots available. So if you're new to Beam and you don't know how to use it, they're doing a training, and probably if enough people ping them, they'll do another one afterwards. So I'm going to throw that, or Mike probably threw that in the chat. I'll throw the link to the training they're doing in June if anybody wants to sign up. Oh, and I'm Emily, Architect Maine. I am drinking water tonight. For all my Canadians still in the Energy New Brunswick, this is a great water bottle. I like this. I don't know.
I can
So,
throw a spoiler in, Emily. The June training is sold out for Beam because I tried to register one of our guys this morning.
ah, darn, it's sold out. All right, we'll send an email over to them that more people want to do it. We'll make them do another one.
And I'm Mike Maines, residential designer in Maine. I am drinking a Lone Pine Brightside IPA, Portland, Maine, one of my favorite beers. I just wanted to note that tonight's topic is spray foam good or bad? We've had multiple shows that sort of cover that topic. We all have our own viewpoints on that. Tonight's really more about when you if you do use it, how to do it right and to make sure things go as well as you can. If you're going to use it, it's a precious resource. It does amazing things. If you're going to use it, you might as well do it right. And Henri is the expert to help us get there. With that, I will turn it over to Ben to introduce himself and Henri.
All right. I'm Ben Bogey. I'm a builder in Connecticut. And this evening I'm drinking a Berlinetta Velvet Pilsner from about 15 miles down the road from me. This evening I have the pleasure of introducing Henri Fennell. Henri is an architect and building envelope specialist with over 50 years of experience in the construction industry. He was a pioneer in the solar industry, introduced the installation technique for field-applied closed-cell cavity-filled polyurethane foam, developed a pressurized theatrical fog quality assurance technique and protocol for ASTM, and has designed and constructed a net zero energy research structure in Antarctica. Of thousands of completed projects, high-profile work includes the Big Dig, the Guggenheim Museum, and the Fort Lauderdale Airport. He has 4 energy-related US and Canadian patents. Henri has installed millions of pounds of foam in every type of building and application. For the last 13 years, he has diagnosed and developed remediation plans and standards for misapplied foam projects. Henri, I saw you speak a handful of years ago, and you taught me a whole heck of a lot, so I'm looking forward to learning more from you this evening. I believe Mike has a slideshow from Henri that we're going to throw up, and we'll let you take us through it, sir.
Yeah, just before we get there, Henri, did we miss anything in the introduction? And what are you drinking tonight, if anything interesting? Stella, good classic choice. Nice.
I don't drink beer that often, but I like it.
Yes. Excellent. Excellent. Well, I will queue up the presentation and just tell me when you want me to advance. We do have a lot of slides, so we'll go through them relatively quickly. And hang on until the end because he has some pretty cool looking failures. Now everything is in the way, so I can't see the screen. How's that? All right.
Beautiful. You ready?
Do it. Go ahead. That's your
Okay. My first comments, I thought before I talked about pros and cons of problems and how to prevent them, that I should mention that even though I do work on foam failures mostly since I retired in 09, I have been I'm still a big advocate of the product, and I installed it for 40 plus years, and I work not only with spray foam but injection foam, which means cavity fill. And you use that when you make molded in place products, but you also can do it in buildings. And I developed a technique for that and Ben already mentioned it back in the late 70s. And I did thousands of homes and buildings like the Guggenheim and so forth with cavity fill foam, polyurethane, not polyurea. Kits and cans and SIPs are two other types of foam products. The two-part kits are basically the same thing as spray foam or injection foam. There are both types of kits, and they have the same quality control, code requirements, even for fire protection, and so forth. If there's any questions about two-part kits, I can help with those. Rigid foam board is another way of installing foam. And we did a lot of projects that used foam board where we had to have a very tightly controlled foam thickness, and we sealed those sheets together. We called it knitting. So that's why I list it. And I, of course, did a lot of structural insulated panel installations. So I can answer questions about that. Advantages: closed cell has the highest R value per inch, meets codes primarily. The big advantage of more R value per inch is you can get a code minimum in a smaller framing size, so you can meet the R49 and 2x12. You don't have to go up to bigger framing members. All three types of foam provide air sealing, and closed cell foam provides vapor control, which is a piece of the puzzle for heat, air, and moisture building science. Okay, next, Mike. Okay, this, for those of you who haven't seen it, this is actually a what's called a hybrid system where they're spraying an open cell and a closed cell product one after the other. The advantage of the open cell is it's lower cost per R, and the closed cell gives you the vapor control. Can you run that one, Mike? Can you make it go? and maybe it won't work. And if it doesn't, that's fine. I apologize, but
Oh, there it goes.
yeah, there you go. Obviously a knee wall attic. So the takeaways from this are personal protection is required, masking is required. You can mix and match with open and closed cell. You can mix and match with polyurethane and other types of insulation as well, but you have to do them in the right order and at the right proportion. The code has the requirements for mixing air permeable insulation with air impermeable insulation, and you have to have the right ratio so you don't have a moisture problem. Okay, Mike. If there are questions as we go, I'm happy to answer them as we go. That way we'll cover more probably, but so what can go wrong? And I'll try to include how to prevent those problems as we go. And this is the slide for consumers. A lot of time, most of my customers now are clients who have had an installation in their home and they have a problem. Sometimes it's building performance. Sometimes it's indoor air quality, and sometimes it's perceptions. And I'll refer to the last bullet on the bottom as internet-itis. And I have some clients who find out after the fact that they go and look on the internet and decide they shouldn't have had it installed, and they want to have it removed, even though there's nothing wrong with it. So consumers don't usually know that SPF is manufactured on site. Who knew, right? And manufactured on site means that if you go to Home Depot and you buy a sheet of rigid foam board, that's made in a factory with quality control, usually ISO quality control protocols, and you assume that that product is of good quality when you buy it. But SPF is actually one of the few materials that's manufactured on site. Sorry, I got distracted by the pop-up there. So polyurethane foam is made on site by different people on different days, different people with different levels of training, people with different levels of understanding of their equipment and so forth. So it's not the same thing as what you would buy in a big box store. Consumers don't ask for references, certificates of insurance. That's the first questions I ask all my clients to find out more about how well they were prepared for what they bought. And the answer is rarely are they well informed about the credentials for the people and the products that they get. They just want to buy foam. And they don't ask for safety information. So a lot of my cases are legal cases, and one of the things that is often used in a case, if there is a foam problem and it's indoor air quality related, is failure to warn, which means that they didn't give the owner enough information to make a good or informed decision about whether it might be harmful. And that especially applies to people who have specific respiratory problems. Some people are more sensitive to things than others, so they really need to know in advance. Most installers only, and of course I'm only dealing with the ones who have problems, so I'm seeing the worst of the worst. I'm not seeing the best of the best, and there are a lot of good installers out there. I want to make that clear. But the ones I see are usually ones who don't have all the literature, don't pass it out to the clients, don't interview the clients to find out if they're might have any specific health issues, and therefore they don't really give them the information they should have. And most people that I deal with, their only qualifier for picking an installer was the price. So one of the things that we want to do, and I'll talk about the architectural side of what we can do. If you have an architect, most homeowners, they just call someone and ask them for a price. But if you're an architect, you have a unique opportunity to actually qualify the installer and the product with your specification. So that's an important option. And there are no standards for spray foam, and I mean the codes cover R value and air tightness and so forth, but they don't. There's no teeth to any of that with relation to the quality of the manufacturing of the product on site. Let's see, quality ensure. Okay, yeah, here's where the architects can use submittals. If you require a spray foam contractor to provide, and I can provide a list of submittals that I recommend, a requirement for the bidders to provide submittals for their product and their application, meaning their means and methods, you can easily rule out. In fact, most installers who are not qualified won't bid. That's my experience. So you want to, it's a way to isolate or qualify the people who would bid a particular job for you. Having a spray foam job commissioned or injection foam job commissioned is another way. Those two things together almost guarantee a quality installation. And internet-itis we already talked about. So any questions yet?
Oh, there's a whole lot of questions. I'm just keeping track of them. Although while you're on this page, there was one that came up directly related to this, which was, I've never heard of pollution insurance. Can you talk more about that? Since you're on this page.
Okay. No, it's fine. When you ask a contractor for a certificate of insurance, and most people don't, you want two kinds of certificates, one for general liability and maybe specific liability, but you also want pollution insurance certificate because liability insurance covers damage to the building, does not cover indoor air quality problems. Pollution insurance covers indoor air quality problems. So it's two different types of insurance. And if you're a consumer, you should have, the installer should have both. And I have a whole paper on how much, what kind of insurance and what kind of insurance company has to provide it. And there's lots of specifics to that. But the bottom line is you want two types of insurance.
Great. I have like 3 pages of questions, so I haven't seen your slides. So I'm like, decide if you're going on or if we're asking some questions.
I'm willing to answer, or you can go to the next slide.
I'll jump in here. Yeah, we have 60 slides. A lot of them are photos, but just I'm not. I don't think we can answer every question as we go, or we'll only make it about 10 slides in. So
that's right.
Well,
that must mean it's an interesting topic.
yes, for sure. No, and the audience is the most we've had in a long time. It's 181 people right now, which is quite a crowd for us. So that's great. Just I'm wondering how best.
Great, thank you.
Yeah, so maybe if one of you guys wouldn't mind just keeping an eye on the chat, and if something really pressing comes up, jump in, and otherwise we'll just push through the presentation. Does that make sense?
Sounds good.
All right.
Okay, now this is me spreading the wealth around in terms of what can cause problems with specific applications or installations. The chemical manufacturers, and I'm talking about the people who make spray foam chemicals, okay? Sometimes they don't provide adequate documentation, and sometimes they don't meet their own marketing claims, and sometimes they use marketing tricks to increase sales that they know installers can't meet. So inadequate documentation is, for example, would mean they give the installer a technical data sheet and an SDS for each foam chemical, but they don't give them the installation guide, or they don't give them the SD the I'm drawing a blank. The report that the laboratories write on the foam, and they don't. And sometimes the documentation will say you want to be 1-to-1 on ratio. Okay. However, there is no machine that I have tested in the industry that is exactly 1-to-1. So my gripe with documentation like that is you got to give the installer a tolerance for their ratio, because even if they are capable of understanding what the ratio is especially on a real-time basis, they don't know how far off is too far. So my feeling is that part of the technical data sheet should be what the tolerances are for anything that has a range. Anything they give a range that they don't give a range to, which is your upper and lower limit, they should have a tolerance for. Don't always meet their own marketing quality assurance claims. Most manufacturers claim that their products are installed by qualified installers, and then they sell to distributors. And the only qualification the distributor has is that you have enough money to buy the product. Nothing about training. And then using marketing tricks, an example of that would be they say you can reoccupy in 2 hours because they know that reoccupancy is a big negative in selling spray foam. And they'll say you can reoccupy in 2 hours, and then in fine print, they tell you what rate you have to take as in units of ACH, which is air power. And I have not met, in my experience with working with 300 projects a year, an installer who could calculate the volume of the space he was spraying in, or knew what the flow rate of his exhaust fans were. Most guys have one fan, one size fits all. That fan is almost never big enough to meet the requirements that the manufacturer specifies. So in my mind, that's a trick that the manufacturers might have. Okay,
Hey,
if there's any
Henri,
chemical manufacturers, yes, sir.
can I ask you a question about that in particular? Because I've brought this up to installers in the past. So
Yeah.
what would you deem, if we can't guarantee that they're having a safe turnover in the air, what would you deem is kind of a safe time limit range before somebody reoccupies? 24 hours, 48 hours, 4 hours?
It's good question. First of all, it should be the length of the cure period, because once the cure period is over, it shouldn't be off-gassing. Second of all, the old rule of thumb was 24 to 72 hours. not 2 hours. And, I can live with that. So I would recommend that they stick with their, the old way in terms of having enough time to be sure that the air in the house has changed and the air in the work zone has changed, so that there are no vapors left in that work zone. Good question. Okay. Any other ones on that topic? All right. Equipment manufacturers, they don't train the installers who buy their equipment. And what I mean by that is the installers, some of the equipment, and I have Mexico City written there. I went to a project in Mexico City. They had the latest and greatest state-of-the-art equipment, and they had a quality control problem there. And there were representatives of the foam chemical company, of course, the manufacturer, the installer, the equipment manufacturer, everybody. There were 50 people there looking at me and saying, what went wrong? And I asked them, I said, what is your you have fault protection equipment built in here. That means that if you're off ratio or if you're off temperature, the machine will shut down so you don't make bad foam. And the representative of the foam equipment looked at me and smiled, and he immediately said, yes, that's part of our equipment, and it's part of the setup of the machine. But he hadn't been there when the machine was set up. And I said, well, what's it set for? So he went into the machine in the computer and looked it up, and it was, some number that was high. I'm going to say 15%. And I said, I looked over and I had everybody there. So I looked at the guy who made the chemicals and I said, what's your maximum tolerance for being off ratio and still making a good product? And he looked at me and he said, I don't know. I said, the hell you don't. Anyway, so I had the manufacturer of the equipment. I said, set that down to 5% and let's try some test shots. And that's what they did. And the other thing they hadn't done was they hadn't heated the supply chemicals. Supply chemicals are what comes in the drums or the totes or whatever form that the materials come to the installer. And this was fall. So the installers were transferring the chemicals at room temperature to the proportioner, which is the pump, at ambient temperature. So I looked again at the manufacturer of the chemicals. I said, what's the temperature for preconditioning? And he said 80 to 90 degrees. And I looked at the installer and I said, well, how do you get these chemicals up to temperature? And he said, well, we heat them in the pump. And I said, that's after the fact. You're off ratio. You have to determine the ratio in the pumps prior to the heaters. So how do you heat what the supply chemicals are coming into the pumps? The bottom line of this whole story is that you have to understand the equipment and the technology that you're working with, and you need to verify that all of the parameters that the manufacturers are providing are being met to make a quality product. So, and my last point there on equipment is most of the parameters don't have feedback from the equipment. So the installers are using the equipment, assuming that it will make a good product without ever verifying anything from the equipment side. Okay. Any questions on that one? It's a big chunk, but now this is something that a commissioning agent would be on top of, all of these, because he would verify everything that the installer should verify, so that when he writes his final report and approves the product, that he's done that. Okay, insurance companies. They don't understand the the foam industry, and most guys who sell insurance, I'm talking about the little guy up in North Conway or somewhere in Maine, up near Littleton or somewhere, Camden, I don't know. They don't know anything about spray foam, so they don't know that there's supposed to be two kinds of insurance for foam installers. So that's not what they sell. They just sell general liability, and that's it. And then the installer assumes that he's covered for everything that could happen. Okay, so my recommendation is that the insurance industry understand the foam industry, or that the installers only buy from insurance agents who understand the foam industry. So, because indoor air quality, somebody asked a question about indoor air quality. That means that there's something in the air that the foam is off-gassing that you need to find out, is that a health risk, or is it just an odor, or is it, is there no health risk?
There are plenty of questions about indoor air quality. I don't know if any of your other slides are going to cover that.
No, I'll talk about it now.
Okay.
I'm sorry, go ahead.
I was going to say, one of the questions was, does off-gassing continue as the spray foam deteriorates? And if so, to what amount, assuming that the installation of the product ratio is correct? Sorry, that wasn't an indoor air quality question.
The off-gassing will, if the off-gassing is relative to how badly the foam was processed. Okay, so, and there is no timeline. I've had clients who had their foam installation for 20 years and it was still off-gassing, and I have clients who did one of my remediation methods, and after 5 years they turned off the system and it was fine. And we tested again to make sure it was fine, but we proved that it was fine after 5 years. There was no testing between 0 and 5 years, so it might have been fine after 2.5. We don't know. But the bottom line is, it's not one answer to how long will misapplied foam off gas. If the foam is not misapplied, there won't be any health issue off gassing.
Are there any telltale signs to know whether or not foam is off-gassing actively?
Well, first of all, the quality of the product, what it looks like, can be telltale. If you see raw chemicals running down the wall, you can pretty well guess it's going to be off-gassing. But the answer is that odors can be telltale. Not all odors mean that the off-gassing is a health hazard. Some of them are just aesthetic issues. And off-gassing, the way to find out if it's safe or not, and you could do this as an architect, you could specify that we do an air quality test after each installation. It basically tells you what chemicals are in the air, which of them came from the spray foam, if any, and which chemicals that are in the air are above the exposure limit according to the EPA. So then do I have any off-gassing that's a health risk?
And who does that testing?
Well, I have a kit that I send to people that are long distance, and they collect their own samples and send them to the lab. and then I go over the lab results with the client, and we use the information that way. But other people, I collect the samples and then I send them to the lab, and then we review the results. The key is to compare. Most people, when they get a foam job, they don't even know what the product is, what brand it is. So what you need to do is to be able to compare the product chemical compounds to what's in the air to be sure that they're coming from the foam. I mean, sometimes we have compounds that are in the air that come from something else, formica cabinets or paint or whatever, just other things besides foam. And you want to make sure you're blaming you don't throw the baby out with the bathwater. So, but the key is to tell the lab what's in the foam so that the lab can look at those compounds specifically and find out if their exposure limits are too high.
And related to that,
sorry, go ahead.
And related to that, there was another question that just popped up in the chat, which is what's possible to do if the indoor air quality test comes back not good after application?
Well, now you're asking me for all my tricks of the trade for remediation. And the answer is there's a lot of different ways, depends on the project. If, for example, if the house has spray foam just in the attic or just in the crawl space, it's a much easier remediation problem than if it's in all the walls, all the roofs, and all the basement. But there are different techniques. Most consultants will say you have to remove and replace it because they don't know how to get a high enough percent result to be sure that it will be safe. But if you understand the exposure limits and the compound, and you can verify which compounds are in the foam that you have in the building, you can actually use lower cost methods, including ventilation. So the answer is there's more than one way to skin the remediation cat, and it's very project dependent.
Great. I'm going to not hijack it anymore and let you move on to another topic, although there's some more questions that keep popping up in the chat.
That
The
was
last one on this list is
it depends.
Yeah, right? That's
Well,
my cue to drink.
Let me put it this way. I would say only 10% of my failure projects have to be removed and replaced. The rest of them, we have successfully remediated it with lower cost methods. And I'm always, as an architect, I have advantages because I understand the building. And as an ex-foam installer, I have knowledge about that industry. So it's a weird combination of backgrounds that helps with that, but doesn't have to be removed and replaced in every case. The last item on this list is the industry. And in this case, this means, there are people in the industry that don't provide adequate information to the public or can't get the code people to put some teeth in the standards. And there's lots of industry people that are could fit into that situation. Okay, go ahead, Mike. Okay, now we come down to the installers. The first question I get is it the chemical manufacturer's problem because the foam is bad? And the answer to that is rarely, because the chemicals are, number one, they go through a long vetting process by chemists and people who understand that they're selling their product, and if it's bad, they're going to lose that, they'll go out of business. And the chemical manufacturers, therefore, and they have the ISO quality control protocols, so it's rarely the chemicals. And I've seen 2 cases where the chemicals actually had a problem, and in both cases, the manufacturer told the installer they had the problem. They covered all the costs of remediation and stood behind their product. So I'm not saying that it can't happen where they, don't stand behind their products, but I'm saying I've never seen it. And that's both 40 years as an installer and 13 years as a commissioning agent or consultant. Okay, don't follow the install. Here's what the installers don't do that cause failures. So number 1 is don't follow the chemical manufacturer's instructions. So, you can imagine that almost every failure I've ever seen could have been prevented by following the instructions. Okay, it's pretty simple. And meet the chemical manufacturer's instructions means they don't know how to meet the instructions. So if the instruction says be on ratio 1:1, the installer should ask him what's the tolerance, number 1, and the installer, if there's anything else that he doesn't understand in the instructions that isn't clear or isn't clear enough or needs a tolerance or whatever, you've got to ask questions. Make sure you can do what they tell you to do. They don't check density with new HFO systems. Now, the point I want to make here is that when things change, and HFO, it means they've got a 4th generation blowing agent, and it's global warming. It's very low number for global warming potential. I was working with spray foam when they changed from CFCs to HCFCs, and I've been through all the generations of blowing agents. And in every one of those transitions, there were failures related to the manufacturers trying to get their new products into production and in the market before they had vetted them in all conditions. For example, a big one was cold weather. So, these guys are all in labs in Texas or or South Carolina, and they're, they never try it in Alaska. And oh, by the way, we found out that, this particular product has a different issue or requires a different kind of processing than it does in warm weather. Boston Whaler was an example of that. When they first came out with HCFCs, they had to scrap hundreds of new boats because the foam shrank. And it was the new blowing agent that caused that issue. So, and that was an injection foam, not a spray foam. There were spray foam examples of that problem, but when we being my old spray foam business got a new product, we made mock-ups and put them outside and tried them here and there and everywhere before we test it on yourself before you test it on a client. So most installers don't verify processing parameters. That means they don't know how to do a high stall test. They don't know how to check the ratio. They don't understand the difference between the temperature that they send the chemicals to the gun at the end of the hose versus the preconditioning temperature for the chemicals in the drum. So they need to verify both of those, and they need to understand that they're not the same thing. I tell guys when I'm overseeing a new installation, I say, if you show up at the job with the chemicals in the drums below the minimum for the preconditioning temperature, I'm going to send you home. And they show up at the job with the chemicals at 55 degrees when the minimum is 80. And I say, why are you here with 55-degree chemicals? And they say, well, we had that truck in the shop overnight. And I say, what temperature is the shop? Oh, probably 55. And I said, how does 55 get them up to 80? So, now we're talking about the guys in the field versus the guys in the front office. And, it's a mess. And then some guys don't understand compatibility issues with some substrates. Now that means, is the foam compatible, for example, with galvanized steel? And maybe that's more of a commercial substrate, but it's not an uncommon one in construction. Foam won't stick to new galvi, but it'll stick just fine to galvi if you spray it with vinegar and rinse it off. So that's or if you use a primer. Same thing with waxy manufactured beams. Foam won't stick to wax, but there are different methods for getting spray foam to stick to waxy surfaces. And the industry in this case did a study, and they determined which method of surface preparation was the most effective, but then there were some second and third place things that would work. And then code requirements. I don't think I've ever measured a foam thickness to see if it met the code that was as thick as the code required. And the comment from the installer was always, but I've got more than that over here. And so the average was okay. Or I've had a guy who had 0 foam in one area say, well, I put 12 inches over there, that should be enough. And I say, the code is a minimum standard, not an average standard. So when you write your specifications or you buy spray foam, you need to say, I need at least 7 inches everywhere. You have to specify the minimum amount and not let the installer do his normal, I'm going to average what the code requires.
The common one, Henri, that I see is I'll get drawings from architects and it says 2 passes of closed cell foam. And I go back and I say, what does that mean?
That could be 3 inches. That could be 2 inches. Yeah, 2 passes, right? Well, see, if the foam, if you need 7 inches to meet 49, and your foam has a limit of 2 inches per pass, two passes will only give you 4 inches. And that's only, R20. So you've got to specify the minimum R value. And when you specify the product, that gives them the R value per inch. That's part of that submittals process that the architect can use to help weed out people who don't understand the codes. Okay. I'm sorry, go ahead.
Can I jump in a couple of related questions, Henri, that I think are relevant?
Yeah.
One is, what do you say to the installers, which seems pretty common, that R30 of foam is as good as R49 of fiberglass or something like that?
Tell them to get the code changed.
Nice.
You can't, you got to meet the code, until the code has a a fine print or an asterisk or something that says if you use spray foam, you don't have to meet this standard or you have a different standard until they do that. And remember this, I will tell you that one of the reasons the R value in the code keeps going up is because the installers aren't meeting it. So the code, people writing the codes are, raising the bar because it's the only way they can get enough to really meet the cost benefit analysis that they do to set the codes. Is there another one, Mike?
I forgot part 2, but I did just get a message from Fine Home Building, who runs our Zoom, that it's okay if we stay on past 7 o'clock. So I'm thinking maybe if you're available, if we can go another half hour. There's just seems to be a ton of interest, and then also probably plan for a follow-up show in the near future to continue things. Just I think we have too much information to cover in the next 7 minutes.
I'm sorry. It's a big subject.
Yeah, no, for sure. No, the audience is super engaged, and there's lots of questions, and it's really valuable information. So just, would that be okay with you? Are you available to go another half hour, or is everybody else?
Both are fine.
All right, sounds good. Let's keep going then. Thank you.
Okay. Yeah, this is slide 4 or 5 out of 60. So
I swear he has
just to let
pictures in
everybody
the
know.
slides.
What's that?
I said, I swear there are pictures in the slides.
Yeah, well, we have everything after this slide, everything after this is a picture.
I just want him to stick around.
Okay, good. Well, it's true. The OSHA requirements, the biggest one, the one that's most often found, is the written safety plan or hazard communication plan. I have never seen one on a job site, and unless I required it before the job started. Architects got to ask for that in their submittals.
Can I interject a question there? So
Yeah.
A while ago, I did a little bit of educating of myself to figure out like what is safe for installers on the job site. And correct me if I'm wrong here, but my understanding is that if installing closed cell in an enclosed environment, they have to have the supplied air type respirator. Just the VOC cartridges doesn't work.
It depends on who you're asking, and that means it's most people use the full body suit and a full head mask, but they use cartridges. Guaranteed you need supplied air if you're in a confined space. Now, you can define confined spaces and look for different definitions, but to me, that includes attics, crawl spaces, anything that doesn't have 2 doors and there's no ventilation. So, I think you can get away with cartridges. If you're working outside on top of a roof, that's adequate. Depends on the environment. And the requirements for confined spaces require you to do air quality testing to verify what you're doing. And to me, that should be a key for making sure that you're using the right PPE.
What about secondary workers adjacent to install? So say we have a foam crew installing inside the building, and then we have a siding crew working directly outside the window.
Is the window open?
Let's say the window's open.
Yeah, well, my quick answer to that is if you can smell it, you shouldn't be there when they're spraying. If you can smell it, evacuate. And the the installer is supposed to provide information, planning, signage, close off the area where they're spraying, and that's all part of this. What's part of the OSHA requirement that I want to see when I look at their written safety plan is the indoor air quality management plan. How much ventilation, what are the setback distances for people like you're talking about? Are they exhausting the fan into the play yard at the school next door? That kind of stuff. You want the indoor air quality management plan that should be part of that. Now, if they take the OSHA sample written safety plan, it doesn't have anything to do with spray foam. Spray foam contractors should have specific spray foam specific programs that cover ventilation. They are atomizing chemicals in the air. And if you were a paint contractor, you would have a different OSHA written safety plan than you do if you're a guy who's working on staging outside. Then he needs the staging stuff, and the spray foam guys need the air quality management stuff. And most installers pay attention to what they're required to do for their contractors, their workmen. Number one, because they don't want to lose them because they're hard to come by. And number two, because they can be fined, so it costs them money. But it doesn't cost them anything if the owner gets sick, or if the owner can't reoccupy within, before the kids get home from school. But, those are things that they should be dealing with in their air quality management plan. Those are safety issues. They don't understand specialty applications or specialty products. An example of that would be the Big Dig in Boston. That was a frozen earth application, sort of like the Alaskan pipeline. We used most spray foam systems you can spray them down to 40 or 30 or 20 in that range. But we were spraying on -30 and, substrates that were frozen. And we used a specific product designed for that application. And, we had a plan for how to verify that we were doing that correctly and that we were keeping the ground from thawing out, because if it didn't, it was going to collapse on us. We were 80 feet down on a vertical cut that was frozen. If that had thawed out, we could be in big trouble. But that's just an example. There are lots of specialty applications that require special products. And they don't calibrate their proportioners. That's back to one of the verifying the processing parameters, which is ratio. That's my biggest gripe, is because most of the failures I see are off ratio. And whether it's due to the equipment, usually it's due to the fact that they didn't heat the chemicals. So they were proportioning the chemicals at the wrong temperature, so the specific gravity of the chemistry was wrong. So they were 1-to-1, or close enough to 1-to-1, but the chemistry wasn't the chemicals that the chemist said I need 1-to-1 for. So they were processing chemicals that were not the right specific gravity for their proportioner. All right, next slide. We're going to get some pictures. Hey, I think. Okay, next slide. And I had these in groups so we could go find them if we had to. This is when I mentioned the industry, this is the industry document for how to quality control spray foam. And you can see the red up in the top. That's their quality control protocol from the industry. Okay. You know, there's a lot more to it than that, let me tell you.
I took a branch off the tree. That must mean the whole tree's good.
That's right. That's right. Well, you know, it should include doing test shots, and I'm going to show you some slides of that if we can get to it. Anyway, this just points out one of those reasons why the installers may have good intent, but they don't have good information. Okay, go to the next one, please. This is an example of most guys, when the delivery comes from the truck, and sometimes it actually comes to their truck on site, meaning they get the delivery in East Podunk via tractor trailer truck, and then you load it from one tailgate to the other. And that's a and the bill of lading says do not freeze. And that's my thermometer reading the temperature. I refuse this shipment and send it back to Texas. Okay, now the picture on the right is a transfer pump. And that's how you get the foam from the 55-gallon drum to the proportioner. So this may be way over everybody's head or interest, but what this was from a drum at the museum in Cleveland, Ohio, for a $500,000 job. And the guys who were there, I went there to quality control with the job, and the guys who were there couldn't get the machine to work. And I said, well, what's your, you know, how long have you guys been doing this? And they said, oh, this is our first job. You know, $500,000 project for a big name building like that. And you see the red cap on the bottom of that tool? And Ben, what is it?
That's the shipping cap.
You got it. You got it. They couldn't pump anything with it because it still had the dust cap on it.
Oh, yeah.
Next slide.
Or just out of curiosity, Henri, was that the Rock and Roll Museum in Cleveland?
I think this was before that.
Oh, okay.
I don't think this is, remember, I'm old. Okay, this is the kind of equipment that somebody who manufactures polyurethane foam products would have in a factory. And there's nothing like this in the equipment that they sell to foam installers, even though the product in this manufacturing may be a $50 product, where the people in the field with spray foam are foaming your house, which it might be a $5 million project, or it might be a $50,000 project. But the bottom line is they give the best quality control to the people who are making the lowest cost products. And it's frustrating because they should sell this equipment to the foam installers for buildings even more than they should sell it to people who make manufactured products. Anyway, next slide, please. Yeah, this is a state-of-the-art machine. This is, I think, the one that was in Mexico City. And as you can see, it's got a lot of bells and whistles. And this machine will shut down if it's out of spec. And if you are an architect and you're specifying a foam application, you would have every right to require that they have a machine with fault detection capabilities. And I will tell you that the industry, this manufacturer now has an aftermarket add-on that can get that capability for almost any old machine as well as current machine. But the installers aren't buying it because it costs more than a penny. So you're going to have to make them use good quality control equipment because they won't do it unless it's in the specs. I think it's just another example. Oh no, here we go with test shots. This is what that document from the ACC didn't include, is how do you do, this is the test shot. So this is how I do it. I do a strip at the thickness that it's going to be sprayed on the building. Okay. And then I cut that open, and you can see the two sides of the cut in the left slide. Of course, you wait till it gets hard. It takes about a minute and a half. And you look at the cells and you look for discoloration, and you look for the color at the beginning and the end of that surfboard when you turn it over. They should be the same color. If it starts brown and ends white, that's lead and lag. That's if you're in this business, you should know what that discoloration means, and you should know how to do this kind of test shot. Next, please. That's looking at the bottom, and you see on the right side, that brown area, that's one chemical coming out before the others. So it's not 1-to-1 in that area that's brown. That's 80-to-20 or something. Okay, next.
Or just before we move on, so like in that kind of situation, if that's in the walls, what's the result to the homeowner? Does that eventually cure? Does it never cure? Does it provide an odor? Is it a health concern?
Well, first of all, this test shot is so you don't spray any in the house. If you see this before, you don't let them spray the house, because this is on a piece of plastic on the ground.
Right.
But the answer is, if you had bad foam in the house, it will never cure, because it doesn't have all the chemistry components that it needs to fully react. So it's the unreacted chemicals or partially reacted chemicals that we're worried about. And everything we're doing is trying to make the ratio and the means of dispensing this product right. And that means the right temperatures, the right equipment, and the right guy pulling the trigger who knows what he's supposed to be doing. And I include the guy because, if the pass thickness limit is 2 inches and you spray 7, and I'm going to show you some slides of a guy who sprayed 12 inches with a 2-inch system, it's going to, you're going to have a chemical reaction that's too hot, and you're going to have product of decomposition, which means cyanide. But you got to pull the trigger right.
That's not great.
You got to spray it the way it's supposed to be sprayed.
Right.
Next slide, please, Mike. Unless I didn't answer your question.
No.
Right? Okay, on the right is a good test shot, and on the left is a bad one. Okay, next slide. Okay, this is the Erie Canal. And this pictures of what it takes to do quality control. This is a marine flotation project, and their first day, they had never done any quality control for any of their work. This is a spray foam. He has 10 trucks and he's been doing it for 20 years. Never had done a test shot. And this was what we did, because in order to get the job, they had to guarantee that they would do everything right. So I wrote the spec for the work, and it included doing everything you see in this picture, and the equipment to do that is on the right. It's not a big deal. and they were injecting up to 7,000 pounds a day, and most residential spray foamers would be doing well to spray 2,000 pounds a day. So this was a really good project for these guys, and they did it right, which was fantastic. Next slide. This is pass thickness verification. It's pretty complicated and the equipment is sophisticated. You cut a thin slice of the foam, you hold it up to a light, and you look at how far apart the knit lines are between the passes. So this was a 2 to 2 inch pass product. You can measure those. Most of them are within 1.25 inches, maybe at the most. And that's all you need to do to quality control it. So that's a good application, and that foam is of good quality. Next slide. This is what happens when this was a rectangular prism, meaning it was the same. It was a rectangle the whole length of it, but the middle shrank. And this is a result of the density of the foam being too low in the middle. So when this was exposed to cold temperatures, this is thermal shock. That's what they call it. And what this means is that the middle, when I do it, I started out doing, 10, I would do every 10, I'd do 10 sections of this and measure the density. Turns out you need the middle third, the top third, and the bottom third. And you want the middle third to be high enough to be above the temperature that the manufacturer specifies for dimensional stability in their ASTM tests. What all that means is if you've got foam that's 1.65 pounds per cubic foot in the middle, it'll be stable. If it's below that, it's going to fail. So it depends on the product, but the elongated cells here are weaker across the grain. It's just like a plant, a tree. If you get a much stronger compression strength from a tree from the top down than you do across the wood. Next slide, please. So this is when I started out. I was doing, I guess I had 8 sections in this slab, and you can see on the left the pass thicknesses went from 1.5 inches to 7 inches. The sample on the right went from 1.5 to 2 inches. Same product, same day, same guy, same gun. And you see all the ones on the right are 2 pounds plus. And all the sections on the left, the middle one is 1.56. So the problem is that the 156 is too low a density, so this foam collapsed. It was unstable. That's the one I showed you the picture of with the T-square. Next slide. Next slide. And by the way, you see freezer and fridge. That's 2 different temperatures we exposed that sample to in order to test for dimensional stability. There is an ASTM standard for that. And if you look at the density profile from those 2 samples on the same job on the same day. Next slide.
Oh.
Those are the 2 profiles. The red line is that you want to be above it line to avoid shrinkage. So this is why we ask the installer to do a density test right after they start spraying, or from their strip test, their foam sample test shot. Okay. Next one. Substrate compatibility. Next, eliminate or plan for known material incompatibilities. This is if you have a list you should have a list of all the things foam won't stick to. Basically, it's a bonding issue. And actually, a main job I did was B&M baked beans, and I will tell you that foam will not stick to baked bean grease. We had to clean the walls before we sprayed the freezers. So you need to know what the foam will stick to, and you've got, I'm going to show you a couple of sheets from a study I did for different materials, but the one that's interesting, consider heat of reaction bond release. If you put ice and water shield on a wall or on a roof and you spray it with foam, the temperature of the chemical reaction of the foam is so hot that you'll melt the tar on the back of the film, and then it will just release. And you'll have tar on the back of the ice and water shield and tar on the roof deck, but they won't be connected anymore. So you'd have to think about what happens to that substrate if it gets to be 250 degrees. That's a little known compatibility issue. But if you do a test shot and a pull test in advance of the work, you always know that the substrate is compatible with the foam, and that's something you can specify. It's like doing when you have them do a mock-up, you can have part of the mock-up be to have the spray foam, and then you'll know if it's going to stick. And the installer can do that with a kit. He doesn't have to take $100,000 truck out to the site and a crew and do that. You can do it with a kit, one guy with a kit in a car. So doesn't have to be expensive. Next, please. So this is B&M baked beans. And the heat of the reaction is part of the problem. But this is the pull test where we sprayed the foam on the glazed tile after we cleaned off the bacon grease. And the pull test shows that the foam has more adhesion than we needed. So next slide. Now this is the results of a study. These are wood products. And you can see the one at the top that says pressure treated lumber varies. That varies, depends on how wet it is. If it's still if you hit it with a hammer and it splashes you, it's probably the foam won't stick to it. If it's completely dry, it will. And then glue laminated beams, you see waxed finish, pour. So that's something you'd have to use a primer or some other kind of prep for a waxy beam in order to get the foam to stick to it. So if you have a beam at the ridge that carries all the roof load because you have a long span, that's fine. You just need to prepare that. You don't have to prepare the rafters if they're dimensional lumber, but you have to prepare that ridge beam so the foam will stick. Otherwise, you'll have gaps. I'll show you some pictures. Next, please, Mike.
Or just a question first is, I've heard an experience that adding a little moisture to like polyurethane construction adhesive or like Advantech adhesive, things like that, moisture helps the foam cure or at least helps it expand. Is that not the case with foam insulation?
It's a 1 part foam, which is what you put around windows and doors.
Right.
Water is the curing. They're water cured products.
Okay.
So you're supposed to, in the instructions on the can, speaking of following the instructions, on the can say spritz the substrate before you use this foam sealant. Spray foam, however, 2 part foam, water is a blowing agent, which means that if you wet the surface or add it to the foam. I don't know how you would add it because everything is sealed. If you add it to the foam, you reduce the density of that material. So you would have very low density material against the substrate when you spray it on a wet surface. And that foam will be so low a density that it won't have any structural integrity. And, you know, it'll shrink when first it'll debond and next it'll shrink. So don't wet 2-part foam.
Got it. Thank you.
And the manufacturer's instructions make you determine what the moisture content of the wood is that you're going to spray against. And most installers don't, you know, I had one guy say, well, what do you expect us to do? Have a moisture meter on every truck? You know, and the answer is absolutely. You need to be able to check the substrate to make sure that it's compatible with the spray foam.
I regularly upset some of our installers when they want to come out and install in January on our project. And I say, no way, not doing it. It's not, you know, it's a cold substrate. There's no way we're going to be able to warm it reliably without putting a bunch of moisture in it. And we're not doing it. But it's like,
well,
but
I guarantee you that I work.
The next job.
I'm from Vermont and I worked year round in Vermont. And I heated buildings. I had remote heating equipment that didn't blow moisture, water vapor into the air from the heater. I had the heater outside in a trailer and a Modine unit that we heated the house with. And I put concrete curing blankets on the outside of the walls. And so I kept the walls warm. I got them up to the minimum temperature and I kept them warm overnight. So you find me a technical data sheet that says what the temperature during the cure period should be, and I'll meet that standard. But I use during the spray foam temperature value as the value for the cure period minimum temperature. So this is metals. You can see galvanized steel, hot dip, core adhesion. Same for mill finish aluminum. Those need to be primed. You can stick foam. I mean, stress skin metal panels all have polyurethane core insulation, but those are all primed or a special galvanizing that's designed for paint prep. Anything that's paint prep, foam will stick to it. Next, please. This is an example of a metal deck that the foam wouldn't stick to. What we did was we put chicken wire up and attached it to the deck, and then we sprayed. So we used a mechanical support for the foam. The galvanized clip on the right, the foam won't stick to that. You can see the crack. So you need to either completely cover that so that it's within the foam and that crack won't affect your air barrier performance, or you need to prime it. Next. And etching means spray it with vinegar, by the way. Okay, so here's a guy who put ductwork in before he sprayed the roof, before the installer sprayed the roof. And then you can see from the outside when we opened it up that there was no foam outside of the duct. This is sequencing, a sequencing error. Nothing to do with the foam being bad. This is to do with the order of the trades being out of order.
While we're on the mechanical side, and I'm going to look for the other question on this, but there's one that came up that said, I've been getting HVAC quotes for full home remodel and addition, and most of the HVAC installers have mentioned seeing premature coil failures on HVAC systems installed in spray foam attics. I keep hearing whispers from the trades about this. Any thoughts on that? While I look for the question that had something to do with plumbing buried in
Nothing to do with spray foam. If anything, it's because they didn't size their system properly because the spray foam performed better.
Okay, there's the answer to that. I don't know where the question about plumbing being, I'll keep looking for it. We have
I'll give you a couple of comments about plumbing. One, you should only have insulation on the cold side of the plumbing. Never insulate the warm side. Okay, and don't surround plumbing with spray foam, because when it expands and contracts, it will squeak and you'll have a callback.
That's fun. I haven't experienced that one.
Well, it will also squeak around the metal diagonal bridging in floor joists if you're spraying for a radiant floor or something, or if downstairs is outside like a parking lot. Those, if they put the two sides of the galvanized steel bridging touching each other, when they move, when the floor flexes, they'll rub against each other. You have to have them slightly apart.
I didn't find the question on plumbing yet, but Ross just asked a question in the chat that, can you speak to closed cell spray foam ductwork for sealing and insulating in vented attics or buried subterranean in the earth?
I've done both. There's no reason not to encapsulate ductwork with spray foam. You have to insulate it anyway. It shouldn't be, unless it's all inside, then you don't have to insulate. If it's underground, I mean, you can put S&D underground and foam around it. I've slid S&D under a slab and then filled the cavity all around it with injection foam. That both insulated the pipe and kept the air out from under that slab.
Probably just want to specify that the ductwork is de-oiled and possibly primed if it's galvanized.
It doesn't matter if it's bonded under there, does it? Maybe. If the foam is all the way around the circle, it should be all right. If it was only on one side, I like your idea.
Sure.
Okay, Mike, if you're ready.
Or this is actually, we're coming up on just about 7:30. I think we could obviously keep talking until midnight tonight, but I'm eventually
Okay.
going to pull the plug. So I wondered if one, you'd be willing to come back for at least one more show. Obviously, there's a huge amount of interest, huge number of questions. You're the guy to answer all of them. So if you're willing, we'd love to have you back on.
I'm here.
Great.
I'm ready.
And two, just we'd like to kind of wrap things up with final thoughts. So is there anything you want to leave our audience with? Pros, cons, advice, or what kind of wisdom can you leave us all with for the next month at least until we hit?
It's a great product.
Yeah.
And it needs to be thoughtfully designed, and then it needs to be properly installed, in the sense that, I mean, I break the processing down between processing and installation. Those are the two keys. Processing means the equipment has to work and the chemicals have to be prepared properly. And installation means spray the right pass thickness, spray it on both sides of the ducts, not just on the front side. So the ducts are, outdoors. I have thousands of pictures of examples of these things. If anybody, if we get to those topics, we can, if you send me the list, I'll do the next one just on the answers.
We have literally 8 pages of questions from people in the chat box tonight. I could definitely see just answering the questions
Yeah,
from the
why
list.
not?
For
And
sure.
probably the other slides I have here. How far did we get, Mike?
26 out of 61.
Okay,
Did
so
great.
my guess is that we will have that the other ones will cover a lot of the answers, maybe. I hope, but I'd be happy to see what the questions are and try to have a slide for as many of them as I can.
Great. I think that we can definitely make that happen. So for everybody in the chat box whose questions didn't get answered, follow up. And I think it was John. I saw you say next week. Maybe not next week, but we'll definitely do a follow-up show. Thank you so much for all of your time. This was awesome. Clearly an hour and a half was nowhere near enough time.
Okay.
Yeah, thanks again, Henri. Thanks. Thank you, everyone, for joining and participating tonight.
My
Have a
pleasure.
great night. Thanks for spreading the BS.
Go Celtics.